So last week we started talking about quadratic patterns, right? There's 2 steps when trying to figure out the pattern. Remember that we're always going to take the order or the step number and we're going to do what with it? Square it. And then, so step 1, you square the step or the order. Step 2 is comparing the squared, x squared, to what? Term value, or the f of x, right? So 2 steps, squaring the x and then comparing the y to the squared number, or the term value to the squared number, okay? So this week, we are going to start making equations out of these patterns and then solving and then relating them to area. Okay, and we're using the area model. Do you remember like the box method where we had like the factors, right? And then we make a box out of it, like that. And then we multiply them together. Mm-hmm. Okay, that's very similar to what we're going to be doing. So we're going to be solving from now on. So I want you guys to look at the opening. It says, how does each expression represent the number of small squares in the figure? So I found this like this pattern, and I want you guys to notice that the area, all those tiles, they're always going to be the same, right? There's just different equations that, or expressions that represent that. So you should visually be able to see, like expression A, 6 times 8 minus 2 times 3. Where do you see those numbers? That's what the question's asking you. Where do you see each of those numbers? So you're going to look inside the square. Where do you see 6 times 8 in the square? Length and width. And that's a good assumption because that's area, right? Length and width is area. So this is the width, this is the length. So where do I see, so I'm going to start off by counting, watch. 1, 2, 3, 4, 5, 6. I see 6. Do you guys see 6? Okay. 1, 2, 3, 4, 5, 6, 7, 8. Do you guys see? Okay. So 6 times 8, that's where you see that, right? And 6 times 8 is 48. Why does it say minus 2 times 3? Jose? Because of the missing right corner. So every time I have a square and parts are missing, watch how I push like, what are this called? Like little dash marks. So draw this and then put like for the missing one, and you can draw it like this on your paper so it's quick. And then just put that, you put dash marks for the missing ones. So the reason they're subtracting is because what's missing? How many is missing? 6, right? 1, 2, 3. So a 3 by 2 square is missing. Does everybody understand that? Mm-hmm. What's 2 times 3? 6. 48 minus 6 is what? 42. So we got that by taking the area of the whole entire square, even though that wasn't completely there. And then we subtracted the piece that was not, the 2 by 3 piece that was not actually there. So now there's another way to do it. You could do it like this. Where do you see 4 times 8? One, 2, 3, 4. And then there's 8 going across. So it would be all of this. Okay, so that's 4 times 8, right? Mm-hmm. So, and then it says plus 2 times 5. Where does the 2 times 5 come in? up here, right? Does that make sense? Can I get my area like that? What's 4 times 8? 32 plus 10. What's that equal? 42. Should I be getting the same answer? Yeah, because the area and the amount of tiles is not changing, right? All right, Iram, where do I get the expression 8 plus 8 plus 8 plus 8 plus 5 plus 5? Where do you see 8? Where do you see the number 8? Go ahead, that's okay.
Oh, okay, so when you're going down on that side, you have to see 5, 8, and then on the bottom of where like a fake one, there's 5, 5, 5.
Okay, so this right here, how many is this? 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 So do you see where that comes in? So if I asked my 3rd grader to figure out how many boxes were in that, this is what she would do. The rest of you should be to the point where you would either do A, B, or D. If I asked you how many boxes. Where do you see 5 times 6? Daniel.
From the like that part that's longer than the other side, and then on the other
This
side.
part?
Yeah.
So this part?
No, that's the 3. I'm talking about the other side. The other side.
This is 3
times 4.
3 times 4. And then this is, do you see how it's broken apart like that?
Mm-hmm.
So you find the area of the bigger one, which is 5 times 6, and then the area of the smaller one. So you just broke it up. You get it now? You got it? Okay, so we're going into area. Area is the equation L times W. You guys understand that? The width is like the fatter part, right? And the length is like the top and bottom. Remember? Okay. Okay, so next, I just want you to write down what I'm writing down. I don't want you to write out the word problem. I just want you to notice what I'm doing. And I want you to write down the picture that I'm drawing, the equation that I'm drawing, and then the solution, okay? So you do need to put on your papers the visual, the equation part, and then the solution part. Do you understand? So you make 3 little columns: visual, equation, solution. So visual means you're going to draw a picture. Equation means you're going to write an equation. Since we're studying area, the equation is going to be set up as like an area problem like that. And then you're going to find the solution. So in a landscape plan, a rectangular flower bed is designed to be 4 meters longer than it is wide. If 60 square meters are needed for the plants in the bed, what should the dimensions of the rectangular bed be? So when they ask you for dimensions, they're talking about, like, let's say like a rug. If you say like the dimensions of a rug, it's like 8 by 10. Or if you have a picture frame, the dimensions are like 10 by 8 or something like that. So think about it like this. You have a flower bed, see? Okay, you don't know, like picture this like rectangle. you don't know its width, right? But you do know that the length is 4 meters longer. What does 4 meters longer than something you don't know? X plus 4, right? So if I say the length is, because I don't know what the width is, right? And when you don't know something, what do you write? X. So I'm going to draw a rectangle. And I said that my width is what? X. And the length is what? 4 meters longer. So that would be X plus 4. Everybody got that? So you see that? Is everybody aware that in a rectangle, these two sides are the same? And then these two sides are the same. But in a square, all of them are the same, right? But rectangles, you have the parallel sides for width are the same, and then the parallel sides for the length are the same. Okay, keep that in mind. Okay, so I have my little visual now. I know that this is the unknown, and then I know that the length is 4 meters longer. Now I have to write an equation. If I'm talking about area, right, I'm going to use this equation. So instead of a W, I'm going to put a what? An X. Good. So I'm going to do length times width. And what is the length times the width equal? 60, which is the area. Got that? Because it told, and I got the information because it told us that, right? So the length is what? Is what, honey? The length is X plus 4. Oh, that's just the units, meters squared. That's how you know that this is the area, square meters. And we said that the width was what? X. And then all of this equals 60. Is that true? This times this equals 60? Yeah. Do we know how to multiply these together? If you multiply X times X, what do you get? Squared. If you multiply 4X times, or I'm sorry, 4 times X, you get what? 4X. And then equals 60. Am I going to be able to have am I going to be able to type a quadratic equation into Desmos calculator using what I have right now? No, because it doesn't equal what? It doesn't equal 0, right? So up here on the top of your papers, I want you to write ax squared plus bx plus c equals 0. So compare the two. Compare what I just wrote up here to this one. I don't have C. Can I get a C?
Yes.
What can I move to get a C? What can I get? What's on the other side of my equal sign? 60. So can't I just move 60 to the other side? Yes. So how would I move that? Good. So I want this to equal 0. Right now it equals 60. So can I just bring this over? Okay, x squared plus 4x minus equals 0. Now what can I do? You solve it. How do we solve it? Okay, put plug into Desmos and look. Well, I'm not that far yet. And look for where the parabola intersects with what? intersects with X. It's important that you write this down. Got this? As soon as you finish copying this, I want you to plug this into Desmos and see if you can come up with the answers for me. Give everyone else some time. So you can get out your phone and put it into Desmos. I'm telling you guys to give everybody a minute. Intersects with X. There's a trick to this that many of you are not going to understand because it looks like, hold on, let me see. I have to zoom out, right? Because it's so big. Okay. Raise your hand if you get the same parabola that I have on the screen. Good. Look at my equation and see, make sure it's the same as yours. Who has the same parabola that I do? Good. Joji, what are my two answers and where do I see them? On the X. So one of my answers is what? -10, and the other answer is 6. I'm doing a shortcut so I don't have to factor these, right? So I want you to come over here and write the two answers. Watch. Okay, so in your solution box, you're going to put X equals what? -10, and then X equals positive or negative? Okay. So we have two answers. Okay. Think about this. If you take the length and width of something, like this is my stamp pad, right? So is my stamp pad, if you just had to guess how many inches by how many inches, what's a good approximation? 2 by 4, good, okay. Think about this logically. Is my width or my length of something ever gonna be a negative number? No, so watch. When you get your two answers, your answer is the positive, okay? So with area, write that down. Area can only be positive. So I'm going to take x equals 6. But that, my question wasn't what are the factors? My question wasn't where does it intersect with the parabola? What was the question in the word problem? Dimensions. Do I know the dimensions? Right now the dimensions are x times x plus 4. What do I need to do with that x equals 6? So look, I'm going to take this, go back over here, plug in 6 and 6. Got that? Okay, look up here now and plug in 6 and then 6 plus 4, which is what? So 6 and then I have 10. What's 6 times 10? 60. Do you see that as your area? So you know you're right. Yeah, so like when it says what are the dimensions, you would literally put the dimensions are 6 by 10, and those would be meters. Okay.
Do we have to do all of this on a test?
Yes, you'll have to be able, I'll show you at the very end where you're gonna have to be able to look at their pictures and see what they did wrong in their picture. So you want to know how to get from the picture to the equation and then to the solution. But you need to realize that the solutions can never be what? Negative. Good. So when you're looking at these area problems, you're always going to do length times width, right? Okay. If it says more, 4 meters more, you're adding, right? What if it said 4 meters less? Then you're subtracting. What if I said it's double the amount of meters? Then you're multiplying. Good, not x squared, you're multiplying by 2. Mhm. All right, you guys good with this? Okay, next one. I want to see if you guys can do this on your own by drawing me a picture first. No, right here. Okay, very first thing that you're going to do. What did you say to do? What are we going to draw? A rectangle, because in the problem it says, and I actually want you to write this one out. So it's 3 sentences. Rectangle has a width that's 5 feet less than the length. The area of the rectangle is 126 square feet. Find the dimensions. So write those 3 sentences. Hardest part of your day today in here. 3 sentences, that's it.
Imagine writing it now.
Okay, I want to show you something. You tell me, don't draw this. Don't write what I'm writing. What's wrong with what I just put?
The length would be shorter than the width. Minus the 5.
This says it has a width that's 5 feet less than the length. So that minus 5 should go where?
On the width side.
On the width side. And then this up top is the length, and that should be the x. Good job. after I draw the rectangle, what is my next step? What equation am I using for area? Good, L times W. What's the L times W equal? And where did you get that from? The word problem, right? Genesis, what's L? What does L represent? But what part is L? So I should put, instead of L, I'll put what? X. Instead of W, I'll put what? If I didn't know what to do next, couldn't I just look at the example I did before? Okay, what do you do next? Just look at it. What would you do next? There's two steps that we didn't do. Don't try to plug this into Desmos looking like this. Because yeah, you have to multiply it and then you have to make it equal 0. So x squared, then what? Would it be plus 126? You're subtracting it, right? It'd be negative 126 equals. At the point where you have 3 terms and it equals 0, what can you do with that? Put it in Desmos. What are you looking for in Desmos?
Where the parabola intersects the x.
Where the parabola intersects with x, good. With the x-axis, good. If you have a parabola, show me your parabola if you've already done it. Good job. Good job. By you plugging it into the Desmos calculator, that saves you from having to do one step, which is to factor it out, right? It would be like what multiplies to equal negative 126, but then adds to equal negative 5. Do you remember that? You wouldn't have one because you just have the x. There's nothing that you can take out of it. All right, see if your parabola matches mine. So I got one over here, which is what? Okay. Negative 9. Which one is it not going to be? It's not going to be negative what? 9. Why is it not going to be negative 9?
Because your x is always
Only positive, good.
So the negative 9, do we just automatically turn?
we didn't turn that into anything. You can't just turn a number from positive to negative. You don't use that number. You're only coming up with one value for x. Even though you essentially have two values, you only come up with one value because you disregard what? The negative, because can you have negative area? No. I just showed you with this, remember? Nathaniel? Okay, hold on. Okay, so it's x equals what? -9, x equals 14. Plug in 14. I'm about to show you the reasoning, why, Nathaniel, watch. So you plug in 14. So 14, and then this is 14 minus 5. So this is 14 by what? 14 by what? 9. What is 14 times 9? So we know that we're correct. 14 times 9, and then we're doing feet, right? Okay. So I want to show you something. Say I wasn't listening to Miss Bolin and I was like, oh, there's the negative. I'm going to do the negative. So, and I took the negative and I plugged it in, right? So I say I have -9, and then I have -9 minus 5. Okay. What's -9 minus 5? -14. Okay. So do I still have the same numbers? But now they're what? Okay. Is that going to make sense if I go and I have dimensions of negative?
It's still equal the same number.
You didn't just turn it into positive. That's why you're going to, so you're correct, but I'm telling you not to use, it's going to give you the same thing, but do not use the negative number, because when you have to do error analysis problems, do not use the negative number, use the positive number. Yes. Yes, because you can only have one answer, right? Because the dimensions, you can only have the one x, because do we have two variables? No, you don't have two variables. If you had two variables, then you could use both of these, right? But you can't, because it doesn't differentiate which x to use. The only reason that I know which x to use is because I know to use the positive number. Can you use the negative number? Essentially, but it's going to give you a negative answer that you would have to turn into a positive. And I don't like telling you just to magically be like abracadabra, bam, you're positive. You can't do that. Okay. So all you have to remember is to make sure that you pick what number for the answer. The positive. Good. Okay, something else that you guys need to, the reason that you have the visual, the equation, and the problem is because you'll have these error analysis problems. And I want to see if you guys can find the mistake. If a rectangle, like this is a rectangular lot, this is talking about like a parking lot, right? A rectangular lot is 20 yards longer than its width, and its area is 2,400 square feet, or square yards, my bad. Find the dimensions of the lot. So let's start by saying, is their picture correct? Yeah, their picture is correct, right? Okay, then look at the equation. Okay, and look at your responses to me telling you just to look at something. Mainly when I tell you to do error analysis problems, what I tell you to do first? Solve it yourself, and then compare what you did compared to what they did. Because your immediate reaction when I said, let's see if they're right or wrong, was, oh wow, that's a lot. Okay. So what if, look, so they multiplied this, they set it up correctly, right? Did they subtract the 2400 like they should have? Yes. Okay, what did they do that we didn't have to do because we used Desmos? They had to they factored it, right? They didn't use Desmos. If you put this in Desmos, okay, that's where they went wrong. So put that in Desmos and tell me what you end up with. W, you can't put a W, so you put a X. Don't waste 15 minutes of your life putting a W in there to later figure out you should have put an X, because Ms. Boland has done that so many times. I'm trying to spare you guys your time. What do you get? Good. You should get positive 40 and negative 60. What did they get? Okay. They got two positives. Which one do I want to pick? The positive one. Okay, so I'm going to take this positive number, not the negative, but the positive one, and I'm going to place it where? Okay, so the top part equals what? And the side part equals 40. So 60, my dimensions are 60 yards times what? 40. Check it. Does 60 times 40, like 60 by 40 yards is 60 times 40, 2400? Yes. Is that the same answer they got? Yes. The only problem was that here, when they factored it, they got positive 60, and that's not correct. Okay. They should have gotten negative 60, because that's what it would actually look like. So do you see how if you assume that it's positive, like if it asked you, the question ever asked you what the factors would be, your factors would be wrong. So that's why you want to use the positive one. So do you guys get that?
Yes.
Do you know what dimensions are?
Yes.
Side, and then just the side times the side? Okay. So keep that in mind. You always do what first? Picture? Visual?
Yes.
And then what? The equation. And it's talking about area, so you're always using what? Yep, good job. And then you set it equal to the area, total area, and then you do what? You have to set it equal to 0, so you have to move that number, right? And then you plug it into, because to have a quadratic equation, your quadratic equation has, in order to put it in Desmos, write this at the top of your paper. It has to be ax squared plus bx plus c equals 2400 or 0? 0. So this is your quadratic equation that you put in Desmos. If you understand this, say me. I said, if you understand this lesson, say me.
I say off again, you're on, Daniel.